Is my screen visible properly? Great. Hello, Richard. Hi, Sandeep. Hi, Lakshman. Hello, Anandita. Hello, Sanjay. Hi, Joshi. So, all right. So let's start now. S- Before we start our discussion further, do you have any questions? Hi, Jairam. All right. So, all right. Please feel free to ask your questions if you have any. All right. All right. So there is a question from Sandeep Mane. The question is that what is cube and roll up in pig? All right. Let me just make notes and Hadoop. And today is 27 September. This is 29 August, 8:30 p.m. All right. So the question is, what is cube and rolled up in pig? So apparently, there seems to be a function called cube and rolled up. There are two functions actually, two UDFs provided by a third party. Okay, provided by a third party, and I haven't gone through exactly what do they do, but I'll have a look at Cube and Rolled Up in over the week, and then we'll let you know. All right. So it's a UDF, as in a user-defined function, as part of some contribution, contrib library, which provide these two functions similar to what is there in case of Oracle. All right, and that's what I know so far, and I'll get into the details and we'll let you know. All right, let me just mark it. Get back. Can we have multiple metastore in a cluster, like one based on Oracle and one based on SQL Server? Right now, I'm not aware of. Okay, okay, because the settings of Hive, we when we define in the Hive's site XML, then we basically define only one metastore, not multiple. Okay. So for example, let me have a look if I can show you. And this is from, All right. So under this, if I get into admin, all right. I don't know the password of admin right now. All right. So I'm logging into this thing. All right. So there under Hive, you can see the various configs. All right. You can see that there is only one database driver. You cannot have more than one as part of config. Right? Does that answer your question, Sandeep? Good, good. All right. All right. And this also tells you how to configure your Hive. You can change the database password and login, and you can also provide a different database URL. If let's say you have installed a MySQL in a new server and you want to keep all the metadata of Hive in that database, you can provide that URL here. Okay, and also in the database you will have to create a user base username and password in which the Hive will be creating its tables. Okay, or you can also say that you want to change this to something else. All right, so all of that is fairly possible. And good, good, very good set of questions. Now moving ahead, next question from Savna is, what all things should be taken care of while optimizing the pig query? All right. This I will take later. Let me take this one first. This is from Savna first question. My understanding is all functions in pig should be uppercase. Okay. So this understanding is a bit wrong. So it should be it should be in the case exactly the way it has been defined. Okay. So you can try, if you remember our example of pig UDF, whatever function name or class name we create for our pig UDF, we have to give exactly the same name. If we give a different one, a different case, then it will give an error. All right. And that's why you see in pig storage, because that's how it has been defined. It has to be exactly the way it has been defined. Most of the syntax, except for these function names, are case insensitive, while UDF and the inbuilt functions are all case sensitive. All right, good question. And now there is one question from Sandeep Mane is, every table will go in one folder. I mean, I will have tweets CSV and user CSV in two separate folders. Yes, but you don't have to deal with folders directly. Okay, I did that because I wanted to give you a demo of how does Hive deals with the data. Okay, uh, you can do it. It's good once you have the clear understanding. But but use load for loading data. Okay. Now going forward. Now there's a question from Shravna is what all things should be taken care to optimize BigQuery. All right. First is that we have to make sure have to make sure that there is there is no shuffling if we don't want to. Okay, meaning there is no reducer if we don't want to. All right, so minimize the need of reducer. Okay, if you know that there is no need of reducer and still it's creating reducers, then you need to pay heed to what exactly are you doing. Second is take care of the skewness in data. Second, try to see if number of phases could be reduced. Number of phases as in uh, number of phases can be reduced. Okay, you can you use merge joins. Okay, and or maybe go co-group. So those are the few things you need to take care of when you are dealing with BigQuery. All right. And also in case there is certain intermediary data set which you know will be which you are sure that which will be used again and again. Please save it to the HDFS to reduce the preparation time. Right, when you deal with pig, you have say a uh, a leads to b leads to c, and then d. And let's say in the meantime there is this very important, you cleaned the data from a till c. Let's say a is your raw log files. Okay, raw log files, and you loaded a, and you basically parsed it so that there are only few fields in this, and you further cleaned it. Okay, this is a clean data, and you further cleaned it with the data types. You passed the data types, and date timestamp and everything is clean here in the form of table. Okay, passed and structured. So you may want to save c into the disk so that you can use that again and again whenever required. Okay, so you can save C into HDFS so that you don't have to clean the log files and you don't have to parse it again and again. All right, that will save the time and will keep it ready for the churning. Also, if you have parsed it and it is well structured, after this point of time, you could also use the same data in Hive and have easier queries for you. For those people who don't know Pig Latin, they might be more comfortable with Hive. All right. Now, next question from very good set of questions, I would say. So these were few optimization steps. Although you will have to pay more attention to what exactly is Pig doing, how much time is it taking, how many map reduce phases are there. By looking at the URL it provides you, Okay, so you will have to pay close attention to those things. All right. Next question is from Sanjay Tandon. How does Hive work on unstructured data like video and music files? First is it is fairly difficult. Okay, but just like just like pig storage. Okay, just like pig storage, Hive also provides the readers. All right, the readers as in I'll come to that. Okay, Hive also provides the custom data readers. We will show you how to read the JSON data and form the objects out of it and use it. And similarly, that custom data readers, custom UDF or custom data readers could be used to load video files and music files and accordingly churn it. Okay, accordingly churn it. So Savna's question, a follow-up question on his previous optimizing pick queries. How can we control reducers using the command called parallel? We covered it during the session. Okay, using parallel. There's a keyword called parallel. If you say parallel 9, parallel 10, those many reducer tasks will be created. All right, great. Great set of questions. And yeah, any further questions or should we continue with our discussion? All right, great, brilliant. So let's start with where we left. We were at the point where we were trying to load the data from into an external table. So, so yesterday we were talking about something called an external table. All right, an external table is basically a window into some data which is lying remotely. And when we create external table, during creation of the table, all it does is make a note of what is the structure of table you are referring to, and also make a note of the remote locations to which your table is pointing. No data gets transferred while creating an external table. No data gets transferred at that point. The data get transferred. The data get transferred only during the query. All right. So external table not only can point to the local data, but can also point to a remote data. It can create an external table over a data store which is not yours. Okay. For example, let's say there is some data provided in, let's say some Wikipedia data is provided by this third party. They have also provided login password for this. All you need to do is you can create an external table which is pointing to the data which is lying in Amazon's S3 service, right? Without having to copy it locally or to your HDFS. That gives you very big capability of churning remote data. And not only this, if your table is external partitioned, if your table is external partitioned, you can have a single table where parts of the data are coming from different locations. Let's say there is a table, you were handling the server logs. Okay, let's say you were handling the server logs, or you are handling the server logs, Apache server logs. The current month's server logs, you keep it on your Apache web server, while and these Apache server logs are available through say HTTP interface, okay, or say some HDFS interface. And after some time, you take out these server logs, all the logs before this current month, all the logs are on Amazon S3, or maybe. So so the point I'm trying to make is parts of the logs based on their chronological status, based on various dates, are stored on different data places. One on Amazon, one on HDFS, one on Apache server, which you can access through FTP. Now, when you deal with such kind of scenarios, either you execute your SQL command thrice on all these locations. Whenever you have to hunt for data, you hunt at every place, or you can create a table in Hive which defines these external partitions pointing to the multiple locations. And whenever you are putting the where condition, the data which lies in that condition will only be displayed to you. If you simply say select star from your table, data from all the locations will come to you. If you say select star from my table where date equals to this, then only the partition which belongs to that date will be considered. Meaning, let's say for last month, if we are querying for last month, Hive will figure out that you are talking about the partition which is on Apache server instead of S3. If you are talking about last to last year, then it will directly go to S3. So based on your partition, based on the way you map your data. For example, the example which I'm taking is given here. Let's say there is an external table called log messages. Okay, it has got hour, minute, second, and in integer, then severity, then server, then process ID, then error message, okay, or info message or whatever log message it is. We are saying, okay, here we are adding something called partition by three columns. Okay, and when we create the partition by three columns, there will be three level of folders in the Hive data storage. Okay, so three level of folders meaning year equals to this, under that month equals to this, and under that day equals to this, and under that there will be all the files that belong to that particular day, that particular month, that particular year. All right, so when we say partition by this, there are three parameters we are providing here, and we can say that alter table log message add partition year equals to this, month equals to this, day equals to this, and accordingly it will create first level folder called equal year equals to this one, and second level of folder this, third level, this is how it will store if it is locally done. Okay, if you are doing it locally, but since it's external, so it's making a note of saying that there is a partition which is for this particular date. Okay, and the actual data is in this location. Actual data is in this location. So there are a few things to note here. We created an external table which is partitioned. How does it recognize partition? By this syntax called partition by. Okay, so we have an external table which is partitioned, and these will behave as if they are the columns in the data. All right, so effectively it will have how many columns? 1, 2, 3, 4, 5, 6, 7, 8. At the end of when you say select star from log messages, it will give you 3 plus 2, 9 columns. Okay, it will give you 9 columns when you say select star from log messages. And while 3 of the columns will be coming from the partition definition, while rest of the columns will be coming from this data. Okay, and this data will be separated by space t. It will expect this data to be separated by /t. Otherwise, if you don't mention this, if you do not mention this part, it will consider the data to be separated by control A. So we define the table, and then once we have defined the table, then we are modifying the table to put all partitions. We are saying for this year, for this month, this for this date, this is the data. For this year, for this month, for this day, this is the data. You can see this is in HDFS based on the protocol, and this is in S3. All right. And once you're done, you can say describe date, and you will have all the details of the partition. Okay, you can also ask for the details of the partition at the later point of time when you say select star from log messages where year equals to 2012. So all the partitions where year equals to 2012 is there, all those partitions will be displayed to the user. Okay, if you specifically say select star from log messages where year equals to this, month equals to this, and day equals to this, then all the data which belongs to those 3 days will be displayed to the end user. All right, great. There are few questions, let me take them. So Sanjay's question is, external table is like a view then? Yes. Actually, as a matter of fact, all the tables in Hive are sort of a view. Okay. And I mean, we cannot say view because when we say select star from the table, the data, it's not executing queries in the backend. It's reading the data. So we cannot say views, okay, because there is a view, that a kind of view in Hive as well. So that we will get confused with that terminology. Next question is from Lakshmanan. The question is, if the data is stored in external, say S3 in this example, I think you meant S3 probably. How Hive can run MapReduce program to execute script. Okay, so when we do that, when we run Hive, then in these cases you will have to the most of the MapReduce will not happen. Okay, for MapReduce it will be reading the data. Okay, it'll be read intensive. But in case of HDFS, it will be able to figure out where is the data, and accordingly it will try to execute the MapReduce. Alright. Next question from Savna is, why the set is not there in HDFS location? Let me have a look what we are referring here. Alright. I think there would be I think there won't be a need of a set here. Let me try it and test it. I don't think there is a need of a set here. Okay. All right. So question is, will it be uh, in alter table add partition? Which one is correct? This or this? Okay. Let me run it and test it. I don't exactly remember which one is correct. Okay. All right. Good. Now, next question from Sanjay is, if we throw a query against cross partition, will it automatically handled by Hive? Yes, that's correct. Cross partitions, as in when we are querying the data which is spanning across multiple partitions, then Hive will take care of it automatically. Okay. So Lakshmi is saying, so can we say external tables are used to load data into managed tables? Okay, so there is actually a very thin line difference between external and managed tables. The only thing is, in case of external table, when you drop the data, it won't impact the input data. When you drop the table, it won't impact the various partitions or various locations of data. But in case of managed tables, when we try to drop the table, it will try to delete all the data which is there in all the partitions. Okay. Therefore, whenever we are dealing with external data which we have no right permission upon, we use the external table. Right. All right. There is a question from Savna. Let me. The UDF we keep local, meaning probably you are talking about udf.jar. Yes, not in HDFS. All right, good set of question. Uh, Savna, is that your question related to the? I think I'm guessing that UDF dot jar is related to. All right. So how it gets executed in HDFS file? Whenever you basically have the data in HDFS for the program, be it MapReduce, be it Pig UDF, every time the jar will be copied locally and then it is added. We say add jar and then we add that, register that UDF. Okay, because the program at the end of it needs it to be handled by JVM, which is running locally. Okay, therefore keeping this data locally available makes sense. Keeping jars locally available is the way it deals with. All right, there is a question from, okay, there's a question from Vidya. Does partition actually rewrite the data into pertaining folder, or does it just show up like the data like that? No, it actually creates the folder. All right, you remember our discussion yesterday when we were trying to create, I'll show you. All right, so when you are creating external partitions, it doesn't have to worry about creating the folders. But if you are creating internal partitions, as in local partitions, when we say add partition and we do not specify a location, in those cases it will create a folder in the location where the folder for the table has been created in HDFS. So what is our login? All right, let's just log in into HDFS and then try to see. All right, here we tried to create the data yesterday, and the data was in what was that folder? Anyone? Slash, and under that there is apps. Under that there was Hive, and under that there is warehouse, right? And where was that data located? So we created some tables yesterday, and was it here or did we create it somewhere else? my DB and human resources. It's not there. So under the warehouse, it generally creates it here only. These are other users' data, which you don't have write permission on. And coming back to what we were discussing, so let me just go through my slides. It would be there in the yesterday's discussion when we were talking about partitions, local partitions. All right. So we created some tables yesterday, right? And all right, let me just log in into the. I'm logging from SSH. If you want, you can log in from the terminal or log in from the browser itself. So we were talking about this table yesterday, and where did we create? Yeah, this is where it is. So yeah, so do you see that it has we created single column on which there was a partition. So therefore, and this partition had two values: qualification equals to 2 and qualification equals to 1. So it has created two folders here. In folder 2, the second table has gone, and in folder 1, the first table has gone. Okay. So whenever we create a partition, it actually creates folder according to that, so that it can be easily managed. All right. All right. You can have a look at it. All right. Next question was from Sanjay Tandon. What happens if the structure of the file at the external location changes? Do we need to sync our external files? So, if the structure is changing, very good question. Very good question. Let's say we are here, we are dealing with this external file location, okay, and somebody has decided to move all the folders which were at the log messages into some other format. So you will have to again say alter table this one, and then mention here we are saying okay, I got the answer what we were talking earlier. I'll discuss again. So we could say things like this. We could say alter table log messages for this partition change the location to this one. So now you got the difference between what is at one place we are saying add partition, at other place we are modifying a partition. Okay, so we can change the location by saying set location. All right. So that answers Sarvana's question as well, that why is there a set here, why is not there. Here we are adding a fresh partition, while here we are modifying a partition. All right. So accordingly, we have to uh, change our strategy. Okay, we'll have to modify our table and accordingly change the structure of our table. So Savna's question is the is that does that mean that we keep our jar file in local? Will it get copied to all the node? Yes, very good point. So whenever we say Hadoop jar or inside pig, we say register UDF. Okay, udf.jar. It is going to take our this udf.jar to all the nodes, just the way here it takes our local map reduce jar to all the nodes. Okay, that's a part of Hadoop's way of working. Okay, that's a part of Hadoop's way of working. So Hadoop jar basically takes that jar, copies that jar to all the locations and start working on that one. Great. All right. So this one has been answered. Yeah. Set location is for altering the partitions. This is for creating a fresh partition. Okay. Notice the difference in the other part as well. At one place we say just the partition, at other place we are saying add partition. Okay, you can see here we are saying add partition and here we are saying just the partition. All right, so I'll just make it bold to emphasize upon the difference. Yeah, that makes sense. Good. All right, let's just summarize whatever we have learned so far. Each table with respect to locations only. Okay, where is my data kind of questions, because that's what will bother you most. So each table has got some location from where it reads the data. By default, tables are located in this directory if you don't specify the location. App Hive Warehouse, under that there'll be your database name, and under that there'll be your table name, and so on. You can override the location by mentioning the location in the create table clause. Local data copies, when we say load data, copies the data if we are saying local. Otherwise, it moves the data if it's on HDFS for both kinds of table, whether it's external or managed. Dropping managed table deletes the data at the location, while dropping an external table does not delete the location, while it just delete the table from the metastore. Okay, metadata is stored on the relational table in Hive metastore. Okay, so when you are dealing with Hive on a cluster, make sure that your MySQL is running in a mode that is accessible to other nodes. Why? Because when a MapReduce query is being run, okay, it has to so that the Hive server needs to access the MySQL machine. If Hive server and MySQL are on two different machines, Hive server should be able to talk to Metastore. Otherwise, it will not be able to create a table or do anything. All right. Of course, you can create a lot of complex select query. Let's see what all can you create. Let's say the most rudimentary form is saying select name colon is comma salary from employees. If you want to give a name to employees table, you can give a name to employees table and access the things like select e.name and e.salary from the table. If you want to join it with another tables, you can easily join it with other tables without any problems, just like the way you have been used to. Okay. In case you want to do the computation or do the projection on various columns, you can do exactly the way you have been doing in SQL. For example, here there are multiple things we are doing. First, we are using the column as such. Second, we are calling a function called upper on the column name called name. Then there is a column called deductions. All right, there's a column called deductions in which we are this deductions is a map. Okay, deductions is a map out of which we are just reading one value. Okay, next is we can further write expressions such as round salary into 1 minus deductions this. So we can write these kind of complex expressions as part of projections. These are called projections. When you select something from a table, it's called projection. We are trying to project one data set as something else. Okay, you could simply do aggregation, select department, count names from this employees group by department, or you can simply say these kind of things. Select count star, average this, sum this from employees without grouping as well. Okay, also please note that in these kind of tables where there is no grouping and you in these kind of queries where there is no grouping and you are doing aggregation over the table, over various tables without any aggregation, please note that this can be easily done without the reduce side work, right? You could do it in the map itself. You could do this in the map itself. Therefore, you can improve the performance by telling Hive to consider map side aggregations as well. Alright, so you can say set hive.map.aggregation equals to true, and this will start setting this is start doing the most of the aggregations as is count star average sum on the map side itself. Now sometimes, so Lakshmi is saying accept average function. Average can also be done because average is at the end of day sum divided by count. So if you can do the summation or sum of all the elements as well as count all the elements on the map side itself, you can easily do the division at later point of time. All right. Now there is another thing because summation, order, all of this does not require any ordering or sorting, so you can get it done in the map site itself. All right. Now the next question is that let's say you are creating queries which are spanning to which are becoming very complex. Say you are cleaning logs, after cleaning logs you're doing other kind of projections and it's becoming overly complex, a single query. So the way in case of pig, we simplified our complex query by breaking it down into multiple steps, right? We broke it down first into load, then into filter, then into for each, and so on. So in the similar fashion, in case of pig, whenever we execute of some dump or store, it executes all the data sets on which that particular data output data set is dependent upon, right? In the same fashion, views also work. To simplify our queries, we generally convert a query into a table. We say that this particular table represents our complex query. We say that this table represents our complex query, And whenever you select some data from this table looking thing, which is a view, and we select the data from this table looking thing, we get it internally execute the query for which it has been created. Okay, so here you can see that we are creating tweets underscore clean as this. So every time we say select star from tweets clean, this query is going to get executed, the part which is selected. If we say select star from tweets clean where something is equals to something, right, it'll get all the columns with these names. So if we say select star from tweets clean, under the hood it's going to execute this query. If we go further and say select star from tweets underscore clean and put a filter such as where text equals to something, right, so that will get added here. In this query there'll be a where clause added under the hood saying where text equals to something, and that query will get executed. So views simplify our process. We will see it as part of the project that we will be creating many views to simplify our process of sentiment analysis. All right, now just like Pig Latin, you might want to create your own custom UDF, right? You can do that using exactly the similar way, exactly in the similar fashion, the way we had done in Pig. We create a class. If you want to create a function in Pig, create a user defined function in Pig with the name called myLower, exactly the same way we have to create a class with the same name, myLower, and then extend UDF. Okay, and once you have extended, you have to implement a function called evaluate, and then inside evaluate you have to write your code. This is the actual code which is doing something. Rest is just the formality. All right, so I'll show you how to get your UDF done, and at later point of time, and before that let me answer your questions. So Sanjay's question is, good questions. So Sanjay's question is, views can be created on both managed and external table. Yes, that's correct. Now, follow-up question is, can we create a view joining a managed and external table? Yes. Okay. For Hive, it's not much of a difference between managed and external table. Now, there is a question from Savana. Question is, will this get stored in Metastore and later we can refer it anytime? Yes, very good question. It is actually stored in Metastore. You can go to MySQL and have a look at it. All right, and you will see the query as well in the Metastore. All right, for those who want to try it out, I can do that for you. Not this. Let's just go to the server where we have MySQL store. And here is our password. All right, so did Control Shift V work for you in the term in here in the VETI? All right, here we are. So we can see MySQL minus U root. Will it work? Yeah, it did work. Show tables. Use let's say show databases, and All right, it's not there. I'll have to log in from the root only, then it'll be show. Never mind. So if you're installing, then you can actually have a look at it. All right, good, very good questions. Can we create a view? This is done. This is done. All right. That Control Shift V is working for everyone. Good. I'm very happy. And all right, inside the browser terminal. I think I should just put it in the manual. So Hive slash Hadoop is always dependent on relational metastore, not Hive slash Hadoop, only the Hive. Okay. So this is from Sanjay. All right. Now here is the question from Sanjay Tandon. Can we do it in HDFS, decoupling removing the dependence on relational server? So you could actually use a very trimmed down version, trimmed down database for this. Okay. And when I say trimmed down, you could go for SQLite happily without any problem. And you don't have to buy a license of SQLite, probably that's completely free. Okay. So, and also in case of trimmed down database like SQLite, what would happen is you do not have to worry about installation of anything. Okay. It's like an inbuilt database. Now, so that is something as part of design of Hive. They had to store the information about tables somewhere. So they stored it in MySQL. They could have as well done in HDFS by creating some kind of a proprietary format, but they have chosen that path. I'm not sure if they are working on that. So H catalog provides those kind of service now. Now under the hood, let me check if hcatalog has started storing the metadata somewhere, or is there other metastore provided which stores the data in HDFS rather than MySQL. It could have been a good idea because right now Hive metastore is prone to a damage. In case Hadoop 1 goes down, okay, or Hadoop data on Hadoop 1 gets deleted, the all the tables structure will get deleted, although the data will remain in HDFS, but the metadata, which is tables, will disappear. So this is something which I don't know if they have worked upon or not, but something worth looking it up. Okay, good point. All right, any other questions at this point? All right. So we were trying to show you how to create Hive UDF. So all you have to do is basically extend UDF, create a class, implement a function called evaluate, and once you're done with that, you create the jar and create the jar, copy the jar, okay, and ship. Okay, once you have shipped it, I'll just write copy to server, or maybe SSH, SCP, not SSH, SCP, or WinSCP, you can say, and then you can say add jar, and that'll be good. So you can say Hive UDF under SRC. You will have So I have created this project for you, and you can basically implement howsoever you want. So just to make sure that we are on the right page, I have done something here. I have instead of inside my lower function, I have done it uppercase. If it's doing uppercase, that means it's doing the right job. Also, we could append something like semicolon just to make sure that it's a sort of custom. All right, and let's just export it. This is just to show you that anything could be done as part of the as part of UDF. So let's say SG Hive this, and I will just create this and then do an SCP. I'll say SCP. In your case, you could either do Win SCP, or you could copy it to HDFS via Hue, and then you could say Hadoop FS copy to local in two steps. If you are not able to install WinSCP, or you don't have SCP, then you can use these two steps. This is also very simple. Okay, you can go to the file browser in Hue and then upload. Okay, or sometimes SCP is not allowed in your organization. In those cases, you can simply go to Hue, upload the file, and then you can say Hadoop FS copy to local. Sounds good to you? All right, brilliant. Now let's try to copy the data. So the data was named Hive. Was it SG Hive UDF? Let me just check the timestamp. Yes, it's for today only, and we can say this Hadoop 3 and Hadoop 17 at Hadoop 3 dot nobigdata.com, and there we go. So is it coming here? Oh, I'm in Hadoop 17 and not this way. Let me just go to Hadoop 3. So to keep everybody in context, we are using Hadoop. I'm using Hadoop set 3. What is the password? Let me copy the password, paste it here. All right. All right. Now here we go. So is it copied yet? Is it too big? All right. All right. So yes, I think this is done. It says sg hive udf.jar. It looks very light. Why would it happen that way? Anyway, let's try to get into Hive. So note that I'm in the same folder. I've started Hive from the same folder where my sg dash hive udf lies. Okay, so we can go to we can simply say add jar, and what was the name of our jar? Sg this. Okay, we can say add jar, and so it says that we have successfully added this to class path and also added this as a resource. Okay, now we can create a temporary function inside Hive by saying create temporary function, and this is the name with which we'll be calling our function. Okay, this is our function. You can see that inside a package called sg, the name of the function is mylower. So it's sg.mylower. Okay, now once that is done, then we can try to test it. Is it working or not? So ideally it should convert this into uppercase. put a semicolon after it. All right, you can see the semicolon. It has put a semicolon after it and also converted it to uppercase. Good. So that means we are sure that this is what is being done. All right. Similarly, we could use some other tables like this. I'm not sure if there is a table called, there is no table called titles. All right. All right. Now, in case in case you want to load some data which is in JSON format. So let me show you what data is in JSON format. Where is my file browser? Here it is. If you go into data and under this, is there tweets somewhere? Sentiment files. Under that again, sentiment files. And there, do you see, just a second, let me have a look. So it says senti upload data tweets underscore raw. All right. Yeah. Here is the data which is in gz format. He is letting us view this file. Okay. So this is a JSON format. This is a complex object which represents a single tweet out of Twitter. Okay. You can format this JSON quickly by using this website. This works pretty fine. And you could just copy paste here and say process. So you can see here that the data has been formatted, and you can see that it's a complex JSON object with, this is the key, the curly brackets represent the object has started, this is the name of the field, and this is the value. The value can further be either an array or primitive value, or it could be another object, just like in this. You see? And under this entities, you see there is another object has started after curly brackets, and inside the object there is a key and the value. And value here is an empty array. In case of user mentions, there is another array of objects starting. So it could be infinitely nested. All right, object inside an object and containing arrays and values and other objects. Okay, so this kind of data, if you have to load, you can use the external UDF, okay, which is that is provided the serializer deserializer. We call them Surday. So there are many Surdays available as of today. Okay, so as somebody was asking me, what if my data is in unstructured format, say video or movies? In those cases, you can use corresponding Surday, just like the way we have used JSON Surday here. After adding the jar, add jar and jar name, we have been able to use row format Surday instead of fixed format or some comma separated or tab separate format. We are using this particular serializer deserializer. Why are we saying serializer deserializer? Because we will use the same class for reading the data, converting the data into records from binary, as well as saving the data from records into binary. That is called serialization, meaning converting a record into something which can be saved onto disk, and deserializer as in reading the data from binary and converting that into records. All right, so you could use these. There are many open source surveys available as of today. For example, if you go into this is a project which is open source on GitHub, and which contains the latest version of the survey. You can immediately get started with it. All you have to do is download this particular jar and then add it. Okay, you can download the jar from here. It would be inside. So because we are using not this one. Okay, you could basically go into any of these. It's completely all right. Yeah, binaries are available here. Yeah, you can download the binaries for any of this and it'll work fine. All right, sounds good. So similarly, if you have some other format for which you need a serializer, you can search for the survey and get it from there. Okay. All right. Now, ordering is a little tricky issue even in Hive. When we try to use order by, it looks great. It orders the data quickly and gives you the records in ordered format. The only downside of order by is that it uses a single reducer. So it might get heavy for a single machine to do the sorting and merging from various places, right? If you have got bigger data, one reducer may not suffice, and thereby it becomes unacceptable for larger data set because you end up with one sorted file which is good, but it becomes very inefficient. All right. So, uh, Sanjay's question is for every unstructured object, we need the corresponding survey. It depends on what format is it. Is it in XML? Is it in JSON? Is it in binary format? Is it in MP3? Is it in MP4? And accordingly, you have to get the corresponding survey. Good. All right. Was he able to answer your question? All right. Great. Now, coming back to the sorting, now since order by did not suffice, then they came up with sort by X. Sort by X was good, but it was creating multiple data sets. If you have multiple reducers, there will be multiple data sets that get created because of sort by. Okay. Now, a question to all of you is, in case of a word count problem, if there was a single reducer, the overall file was sorted. Now, if we change to multiple reducers, say two, how many files are created? Two, right? Good. So two files are created. Are these files individually sorted by word? Okay. Now question to you is, if we concatenate, if we concat these files, is the output sorted? That's correct. Are these files sorted? Yes. No. What if, what if we want multiple reducers and we want to concat the files and still the data is sorted? What would we do? Anyone? Or in other words, let me put it in another words, or we want the data going to different reducers to be mutually the data ranges going to different reducers to be mutually exclusive or non-overlapping. That will be better word. Non-overlapping. Yeah. So what if we want multiple reducers and we want such that the output should be such as all those two files should contain the words that do not overlap the ranges. One should have something like apple a to j. Okay. Say file 1 should have all the words. File 1 should have all the words from a starting with a to starting with j, and file 2 has from k to z, from k to z. What will you do in that case? Vidya, do you want to change your answer? Lloyd? Good. So this hint worked, the last one, and the answer is we use partitioner. Great. Great. So everyone with me on this. Vidya, Sanjay, great. Great. Thank you, Lloyd and Sarvna. So what did we face just now? We had some data, we wanted sorted results. If we had one reducer, everything was beautiful. But the moment we had multiple reducer, although the data was individually sorted, but ranges were overlapping, because if we tried to concatenate the two files, the overall results needed sorting again, which is very time consuming. Now, to avoid such kind of scenarios, what we did was we created partitioner. Now, exactly the same story is with respect to the Hive. When we had a single reducer, that is order by is equivalent to this situation. Okay. Now sort by is equivalent to this situation where we have multiple reducer. So if you use a syntax called sort by, the data will not be properly sorted. Individually sets will be sorted, but not the overall. So we used partitioner. That's why we used partition, and using partition is equivalent of distribute by. So we use distribute by along with sort by, right? because we use partition and then we say we have multiple reducers, right? So we use proper ordering requires first distribute by and then saying sort by. So generally these both the columns are same. Okay, this is your column name. Okay, so did it make sense, this discussion? So distribute by x, make sure that you are trying to, it will split the data such that reducer 1 gets the range which is not overlapping with the range which another with another reducer. All right, and that's where, to combine both the points together, is another syntax created called cluster by. When you say cluster by x, it's equivalent of saying cluster distribute by along with sort by. Okay, so it's when I say cluster by x. Okay, so partitioner will make sure that that x column is non-overlapping in the two reducer, and along with that, the along with that, our sorting in case of map phase, the key is the same column and there are multiple reducers. Okay, so at the end of it you will end up using cluster by x. All right, there's a question from Savna. Let me take those questions now. So was I able to explain when do you use what? The question from Savna is that word count, it would not cause issue, I guess, though the sorting is not done. Yes, that's correct. The same key goes to a single reducer. That's completely correct. But but if you want to have a single file, if you want to concatenate and you want ordering as well, then the data will not be ordered correctly. All right. So you can so you can have, say, part dash r 000 containing things like apple, orange, and give me something with um, yeah and zebra. Okay, while part 1 might contain um, art and say oracle and say banana and Jew. See that? So these two files, although they are individually sorted, but the result is not. Is that your question? Let me just put his answer. Yeah. All right. So yes, you are right. In case you are basically trying to do the word count, it is successful. Correct. But if you are trying to also sort the words and have a single file in which the things are sorted, and then you would not require, you would have to have some other way. Okay. All right. So same is a case of bucketing, as in when we are clustering by something, we can tell that please use these many buckets, or you can say these many reducers. That's what is called bucketing. Okay, the way we have just discussed what is cluster by. So when you have to specify number of reducers, you can say these many buckets is what I want. All right. So this is although it doesn't make much of a sense to have partition by and cluster by together. Okay, you can simply use either the partition by or cluster by. Okay, just to give you the example of syntax, how are you going to use it? You can use it in this way. Okay, so let's say you want the result to be sorted by user ID. You can simply say cluster by this and also tell how many buckets do you want. Okay, and under the row formatted, here you can go into further details, as in how you want to uh, various fields should be terminated how. Okay. All right. And here it's stored as sequence file. If you remember our sequence file as part of MapReduce discussion, whenever we want to store something in a binary format so that we can later on take care of it, then you can use the sequence file option. Okay, would not have to, it does not have to parse the data again and again. Sequence file is far more efficient than CSV or any other format. Now there's a question from Sanjay. Question is, so cluster by just improves performance even though things can be done on a single reducer. Yes. So if you are okay with single reducer, you use order by. Otherwise you use cluster by. All right. So answer is yes to your first part. Good. Any other questions at this point? Let's go for a quick demo. So we can download the data quickly. This is the how does it? Yeah. So let's download this movie lens data, which basically the gives you the where is Asgiri's data? Let me just move my files here. All right. So let me download this movie lens data. Ouch. I'm trying to download wget from wget. Okay. So I've just downloaded this movie lens data. You don't have to download, you can copy from my folder. So here, this contains the details about movies. Who has rated which movie with what? Okay, we've just downloaded that file and it is a tab separated file. We can have a look at, say, this file. Where is our file? U underscore data. Okay, tail minus f, and where is the u dot data? This is the u dot data. Okay, so you can see that here it says user id, movie id, and how much this user has given this particular movie rating, and at what time is the rating given. So out of this we want to do some quick data churning. So we load this file u.data and try to do the churning. Okay, right now we'll just do very quick thing. So we create this table. Okay, we are launching Hive. So we are saying show databases. All right, so what was the database name which we created yesterday? Anybody? This is the database we created yesterday. Use our database, and then we create this table. We create this table called u underscore data, and when we say select star from u underscore data, there is nothing in it. All right, and to load our load our data into this table, we can say simply load data local in path, and we can say give the location of this folder and then overwrite into our table. We are saying delete the older data whatever is there in this table, and and upload it. Okay, so our location, actually location doesn't matter, we can simply say this. Okay, notice this these keywords local and then override. Okay, local means we are trying to load data from local, and override means whatever data is there in u underscore data will get overwritten. If you remove this override, the data will be appended to the table. Okay, all right, so this table is getting uploaded, this data is getting uploaded. You can quickly have a look. Select star from u underscore data, limit 30. So you can see that quickly it has shown us 30 records from this table. All right, now you can do lots of magic. Let's say we want to find out, let's say we want to find out various kinds of rating. Okay, you want to find out what is the average rating of every movie. Okay, let's say we want to find out what is the average rating of every movie. How would you do? Anybody quickly? Based on this, you have these columns: movie id, user id. Anybody can help me? So we can say select movie id and say average rating, right, from from table called udata, and then good, group by movie id. Thank you, Sanjay. All right, now let's try to execute this. Sounds good? Is everybody comfortable with this? So what I'm trying to do is I'm trying to compute the average rating of this movie, of every movie actually. So once that gets done, you will see the results. Also, assignment for today is for each movies you have to find out how many users have voted. Okay. Now, once you have done that, second problem is little more tricky. Problem is for movies having more than 30 ratings, what is the average rating? Create your own database in Hive before you start doing anything. Okay. Do not pollute anybody else's database because we are going to use the same login name for all. Okay. So create your fresh database and then uh, solve these two problems. Okay. Let's see who can. All right. So this is what it has computed so quickly. So we were able to compute the average rating. Now this average rating has got a problem. The problem is that even though one person is a biggest fan of a particular movie, he will come around and rate it as 5, even though nobody else has watched that particular movie. So there is a skewness, there is a bias in this particular way. So to solve that bias, what we decided was we will only compute ratings for which there are at least 30 users have rated that particular movie. So your objective is to find out the average rating of only the movies which have minimum number of 30 ratings. Okay. So all right. So basically your exercise, the second exercise is a combination of this particular one and the first exercise. Okay. So this is a combination of both. So you have to find out the average rating of only those movies which have been rated by at least 30 users. All right. That's pretty much from my side on Hive. Let's take the question answers on this in the second half and carry on our very important discussion of NoSQL in the second half. All right. All right. We'll be back in 10 minutes. Okay. We'll be back in 10 minutes. All right, should we start now? Is everybody back? All right, so only Sarvna is back. Should we start now? I want almost everybody to be as part of this because this is going to be very important. It's as important as the first session was. Great, great. So Sarvna is back. Sandeep is back. Anandita, Sanjay, Kanaga, Vidya is back. So there are 15 people. I'm waiting. Maybe majority. The moment majority says yes, and we will go ahead. And you will understand the concept of majority when we discuss the automatic leader selection. I think we have already discussed as part of our HDFS Federation HDFS. What was that high availability part? Okay, so 1, 2, 3, 4, 5, 6. All right, is everybody back? Please say yes, and we can start. So still the minority is here. All right, majority is up. Good. All right, let's start with today's session. What's happening with this? Good. All right. So we have discussed something called Hive, which gives an impression that it provides you a database, but it's basically providing you only the query language. It does not provide you a way to write the data at a very fast pace. Okay? So now let's start with a very simple thing called HBase and NoSQL. All right? So what exactly is NoSQL? If you have no clue about SQL, you can proudly write in your resume that you know NoSQL. All right? So yeah, that is one big use case of NoSQL. But that's just for the joke side. Now, before getting into NoSQL, let's be clear about various definitions. So, first is understanding scaling out and scaling up. Again, the same example where you had a single cart with a single horse and you wanted to carry more stuff in that cart, which a single horse and single cart is not able to carry. There are two ways to it: buy a new cart, buy a new bigger, buy an elephant, and put them and let them pull. Or you could add more horses in the cart and add more carts as well behind the previous cart, just like a train, and start pulling it. That way you have single cart and you are being very practical. You are not trying to get more things done or have more carts to carry the stuff. Now, while adding more horses to the cart is called scaling out, and adding an elephant to the cart is called scale up. Scale up, scale out, vertical scaling, and horizontal scaling. Okay, those are the words you need to keep in mind. So, scaling out is horizontal scaling, more horses. Scaling up is vertical scaling, as in buying a bigger elephant. So there has been always the trend of buying the best server possible, and we are going to go through that discussion today, that how people used to manage the load, how people used to move to bigger server when they struck with more load, and how that did not solve the problem. How did vertical scaling up did not solve the problem? And the ultimate solution was to move ahead with horizontal scaling. Okay, we are going to discuss that part today. On the prima facie, it sounds great to run a MySQL server or Oracle server on a machine which has some 16 cores and has a memory of 200 gigabytes and having a SSD and a hard disk. So this all sounds great, but in reality, that's not something that is good enough. All right, we will we will go ahead, and that was the main reason why the focus need to be shifted from scaling up to scaling out. Instead of buying really high end server, the focus need to be on the design of the product, design and architecture of the product, such that more and more servers could be added in the network to facilitate your application load balancing. All right, now let's go over this nice story. This is actually what used to happen at that time. Okay, I think I will just go through this. All right, so this is a story of 2004 or 2005, those years when NoSQL was not really popular. In 2000s, that was the story that was quite common. So the usual story was you are trying to launch a good e-commerce website and you are very happy about it, and on the day of launch you just moved the database from local workstation to something remote which is shared and remotely at a public machine having really good bandwidth. Now as the server becomes more and more popular, so you launched this website and next day there was some press release and suddenly you get lot of load. Okay, your service is becoming popular, too many reads are hitting the database. Okay, as usual, when too many hits start hitting your too many read requests are is starting to hit your database, what do? You install a caching solution such as memcache. Okay, meaning you start caching the commonly used data. And if you are from DBA background, you will understand that the moment you start caching the data, you have your data has become inconsistent. Okay, sounds strange, but in reality, that's the case. So let's say we have cached some data into the memory, right? Caching the data meaning keeping the data ready and available for your users. For commonly used queries, commonly used data sets, we load it into the RAM and is available to be served to all the users. Okay, so for this, we start doing the caching. Now, what happens in case the data you have cached get altered? You have to reload the cache. And by the time you reload the cache, you will be serving the old stale data. Meaning, user will be getting the older data. Older maybe by few seconds or maybe by few minutes, but it's older, right? And the moment you say older data, it means that you have grown inconsistent. So that acid property is no longer valid the moment you start caching the data. Next is, so you have installed this caching solution and are happy about it. It actually solves a lot of problem. It solves a lot of problem. The caching solutions really work well. After some time, what starts happening is the service is still growing popular. Too many writes are hitting the database. Okay, too many writes are hitting the database. So what you do? So I mean, as an experienced DBA or experienced sysadmin, all you do is you scale MySQL vertically by buying up really high-end servers containing 16 core, 120 gigabyte RAM. As of today, this limit has gone really high. Okay, and 15,000 RPM. What is the RPM which you generally use? You use around 5,000 RPM hard drives right now. Okay, this has gone different as of today. As of today, you get 32 cores machine, really high-end servers having something like 200 or 300 GB RAM. Okay, and having the SSD as well as the normal hard disk. So the second attempt to solve the problem is to to take the database. First, implement a caching solution. Second, upgrade the hardware. And third used to be so yeah. So we will go into the third and more details. So now once you have upgraded the hardware, for some time you will be pretty happy, right? You raise some fund, and when you raise some fund, you hired many product managers and the developers. You kept on adding more and more features, and when you started adding more and more features, the query is getting complex. For example, Amazon's detail page as in the page from which you do the buy now button. Okay, it has around 200 features. Okay, ratings, byline, title, byline as in author name, brand name, author name, asterisks, ratings, and and buy now button, prime button, and header, footer. There are around 200 features which are displayed on Amazon's page, right? So as more and more features are getting added to your product, the query's complexity is increasing. Okay, now every time a request comes from the user for a page, there will be many joins that would happen, right? There will be too many joins that will happen, and at this point of time, the if you are from a background of DBA, you will hate this part. Okay, you might have to denormalize. What does it mean by denormalize? You gather all of this data, put it in a single table. Data of all the features, you put it in a single table so that you just have to query one table to serve the data. Instead of querying 200 tables and joining them and serving the data, you will have to denormalize. This is something you never read in the DBA school. Okay, and I have gone through this phase. When we were at D Shaw, we had one Postgres DBA who had a PhD in databases and was one of the core developers of Postgres. Okay, so he said that let's denormalize everything, and we found it very awkward at that point of time because our data was growing to a very high limit, and we were in the same phase. So, so coming back to the point, so at this point, you have sacrificed two things. First, the normalization, which is provided by database really well. Second, the acid property, which is consistency, out of your database. Now your database is still gaining the popularity. Things are getting too slow. So what you start doing is you stop doing all kinds of server side operations. Server side operations as in database side or any other operation such as triggers, indexes, stored procedures, all kinds of server side things we start delegating to the client side into the JavaScript or into your web applications. So even after doing this, there will be some queries that will be too slow. So what we start doing for those slow queries is pre-materializing them, anticipating that people are going to call these queries, and hence we prepare that data that it needs to run upon. Okay, now at this point of time, when you have pre-materialized things, you have created denormalized databases. So as expected, when you want to write the data, it'll become slower, because if you denormalize, then you might have to insert data into multiple tables, as well as when you are having pre-materialization, you have to update the cache and update the pre-materialized tables as well. Now at this point of time, the writes will get slower and slower, and what would you do is you will try to make it faster, and therefore you will start killing all the secondary indexes. If you remember the databases, when you insert a record into database, all the triggers, all the stored position, all the triggers or the indexes get updated. So you avoid triggers, you start avoiding the secondary indexes. Let there be primary indexes, which is not too costly, but secondary indexes we start killing one by one. Now at this point of time, if you notice what you have done, you are not using any facility provided by relational databases. Okay, facilities such as ACID properties, transactions. If you try to put transactions in a high-end, high-frequency system, then you will realize that the transactions will slow you down really, really bad. Okay? So in one of the stages, you will also try to kill transactions to make it faster. Okay, so this is a classic stage almost every company which survived had to go through. Those people who did not evolve so fast as per the demand, they basically vanished. And that's what started happening in the beginning era of the e-commerce. So there was a time when Amazon got blacked out in US on the Black Friday. The reason was they were not ready. They were still using the older tools, and they could not handle the load on Black Friday. And there was many such situations where which companies like Amazon go through. And this is not something hypothetical. If your service becomes popular, this is a problem which is not really nice to have. Most of the other problems related to the growth are nice to have, but this one problem, if you did not solve, you will not able to solve it when you are in those shoes. Okay? If you do not anticipate the request, you do not handle that kind of a load, in the design itself, you will not be able to handle it at the last moment. And that was the reason why most of the e-commerce companies actually used to shut down. They had these black days for a month where they could not bring their data back. They could not bring their websites up. So Ravikant's question is, we are caching the queries and not the data. We are caching the data. Okay. When I say pre-materialize, what exactly are we saying? That for the common queries, we looked at our logs and found that there were these many queries for these many and have been called that many times. We start pre-materializing them. Pre-materializing means pre-preparing the result of that and keep the data ready. Whenever that query is coming, we just pick the data from that table and give it instead of actually executing the query. Now, you might notice at this point, we are not using any feature from databases anymore. Neither we are using the ACID properties, nor we are using transactions, and we are not also using the the joins of databases. Along with that, we are also not using the indexes and triggers and and stored procedures. Okay, so the question arises that what's the point? Why are we having such a hefty thing to handle our system when we are not using any of those features? At that point of time, people like Amazon, who had been hit by this problem, came up with NoSQL. There were few more companies who had parallelly developed such kind of systems, which were very rudimentary data in and data out without any bells and whistles. And that was the starting point of NoSQLs. All right. Is everybody with me? Are you able to relate with this kind of situation? No? Have you ever faced this kind of situation? I have been through this situation at least twice. All right. So the dynamics, when the data starts growing, the dynamics start changing. Okay. Just the way the Newtonian's laws do not apply uh, anymore when the speed of an object goes into into the limits of the speed of light. Similarly, the dynamics of managing data starts changing when the data size grows or data velocity grows higher. And 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 so is these cases of relational databases. All right. Now, again, so that was a good case study, and not case study as in it's a usual case with most of the people. It's not like a classic case study in the sense. Next is that why do we use NoSQL? So there are three reasons which we have already covered earlier also. To store big data. When we want to store really high number of records with high number of fields, then we use NoSQLs. Such kind of data which one machine will not be able to handle in terms of disk IOs as well as in terms of the volume. So when the data grows really bigger, then you use NoSQL. Second is high availability. When you require more number of TPS, TPS is a transaction per second. When you require more number of TPS, then you go for NoSQLs. Third is to scale out. Whenever we are in a situation like this, where we have unexpected or anticipated increase in our load. Today there are 1,000 users, tomorrow there will be 10,000 users, and day after that there might be 20,000 users. So we have to have our plan very clear that how are we going to handle this? Can we add more machines to handle this load? Okay, so to answer to that question, most of the NoSQLs are designed in a way that we should be able to add more and more machines to share the load at any point of time. Okay, so it should not be that we have to shut down everything, add some hardware, distribute the data, and then start up the cluster. the NoSQL has to be such that it can be started at any point of time. Okay, so that's why we use NoSQLs, and these are the common properties of most of the NoSQL databases. NoSQL started as a common handle. There were some people who faced this kind of issue, and then at the end of it, they said there should be NoSQL. Okay, so the handle became popular. It's a Twitter handle. So some people were going to attend some conference and they created a handle and it became popular, NoSQL, and that's where the name of NoSQL databases comes from. So a NoSQL database is designed for distributed architecture, and when we distribute some data across the cluster, we should be able to identify uniquely each record that's being spread across, right? And therefore it is very imperative that every record has to have an identifiable unique ID. It is not SQL, not only SQL. This is called not only SQL. Some people have tried to uh, make meaning out of NoSQL, although it was just created as a handle quickly. And the objective was to say that we are not able to do relational stuff when we are on a high performance. Okay, when we have to provide high performance, we cannot go for non-relation. We cannot go for relational. So it is non-relational databases. It's a class of databases. It's not a single databases, and all those databases seems to have these common properties. Most of these databases are open source. Reason being that if they are proprietary, nobody will adopt. Because any data centric application where the data gets logged in, because inherently every database is a data lock-in. You put in the data and data is inside the database, right? Tomorrow, if this database says no, that it denies to give you the data, your data is logged in, right? Therefore, almost everybody prefers well supported database with an open source license. When I built Tbits Global in my last startup, whenever we used to go to pitch enterprises, we used to sign an agreement in which we used to say that here is the source code of our document management system. In case our company closes down, source code is yours. So the moment when I sold the company to somebody else, okay, our existing customers insisted that since they are going out of support, they needed source code. Okay, so there is a reason why any data lock-in product has to be open source, and only those NoSQL products have survived which are open source. And for that matter, Hadoop is popular because it is open source. So next is it's horizontally scalable. Almost every NoSQL out there, there are 150 NoSQLs in the market, and all of them are designed with horizontal scalability in mind. They are not having any schema rigidness. Okay, the reason is same. The case study which we discussed, that when you try to impose in schema, it becomes rigid and it becomes difficult to provide that kind of performance. Easy replication, as in easy to copy the data, easy to replicate on new machines. Simple API, manage huge data. Simple API, as in almost every NoSQL has their own kind of API. There is no standard as SQL. Okay, MongoDB has something called aggregations. MongoDB is also a NoSQL database. HBase does not provide any query language. Okay, while Cassandra provides CQL, Cassandra query language. Okay, none of them provides a proper SQL kind of a language. Okay, and most of them have been designed to run on commodity hardware, and they will run happily as long as you have more and more machines who can handle the loads. All right, there are different kinds of NoSQL database data stores. All right, let me answer your question first. So Sarna's question is, will it handle transactional data? No. Okay, we will come back to that question, why it won't, why none of the NoSQLs are able to handle transactional data. And when I say transaction means acid properties. Acid properties, do you remember acid properties? Do you remember acid properties? All right, help me. So when we talk about any databases and the transactions, there are four properties A, C, I, and D that a database need to support in order to say that we can handle transaction. Okay, A for atomic, C for good. Thank you, Lakshman. Joshi, okay, Savna, good, good. So, uh, all all right. Thank you, Ravikant. Yes. So atomicity, consistency, isolation, and durability are the properties of a transaction which every database has to support. Okay. In the true sense of transaction, providing these four, none of the NoSQLs are able to do that. All right. Now coming back to the next question. Brilliant. In NoSQL, the SQL part is still support the query language, or is it just the same? So as I was telling you, different databases support different SQL standard. Okay. So for example, MongoDB provides aggregations and MapReduce. Okay. Cassandra provides CQL, which is similar to SQL but not very rudimentary, very rudimentary. And CQL and MapReduce as well. And HBase only provides get and put, kind of very rudimentary libraries, and MapReduce. All right. Yes. So Lakshman's question is, does it mean if we need transaction support, we can't use NoSQL, or are there any workarounds? So I would say that we cannot use transactions in NoSQLs. Okay. So if you need transactions in a strict sense, you might want to break it down, or you can use a hybrid solution where for transactional data, you continue to use MySQL, and for non-transactional data, you use NoSQLs. Okay. Because the moment you try to start transactions on any high load databases, it will slow it down. It will slow it really, really badly. Okay. So at a point, either you can have really high, fast speed or a transaction. All right. So Theoretically, NoSQLs have been bucketed into four different kinds. First is called column-oriented or wide column. Column-oriented databases are databases which are having the structure of like a table. These are most closest. These are the closest to our definition of a table. All right. Second is the document-oriented databases. Document-oriented databases store generally a complex object. A complex object is known as document. Okay? An object an object such as a JSON object is used in case of MongoDB for storage of one um, uh, storage into MongoDB whenever we are trying to create data. So such kind of databases are known as document oriented databases. Okay. Say for example, you want to store the information about TV shows. A TV show contains season contain episodes contain reviews, and episode also contain the cast members. Okay. So there is a complex object structure. Either we could create, say, around 10 tables for these this kind of structure and join them, or you could use a document oriented database and use only a single table to store all of this information in the form of JSON object. So MongoDB, for example, calls the table as collection, and each row, instead of a row, it has a JSON object. All right. The third kind of databases is key value. Key value as in these are the most primitive databases. This is where the whole story about NoSQL started. The first database was Dynamo in true key value sense. Okay. So these were very primitive databases. It was basically kind of two column only, as in it was more like a hash table. You have key and the value, and both were string in the beginning, though both were plain text in the beginning. Later point of time, more and more databases came into play. More and more databases came into play and started providing you the storage into key value pair, and value could be a large complex object at later point of time. All right. The fourth kind of database are the most latest, and the fourth kind of database is the latest in the industry, and these databases are called graph databases to store the graph of your friends, for example. So almost everything could be represented as a graph. All right. Be it a Google Street Map, or be it a friend relation connections from Facebook. So so the examples in graph database are Giraffe, Neo4j, and others. Okay. All right. So these are the four kinds of databases which are in use as of today. And based on your need, you choose the database. So current status in the industry of NoSQL is that you generally choose the database after you have identified your problem statement. Let's say your problem statement is you want to build a local search engine or hyper local search engine. In those cases, you will go with database like MongoDB. If you are looking for complex analysis of a graph, then you go for Giraffe. If you are just looking for a very highly scalable store for your e-commerce site, you are good with either column oriented database or key value data store. All right. All right. So there is a question from Sanjay. So is NoSQL not good for data warehouses too, where data is stored as read-only? So to use this kind of databases which have been highly tuned for high performance request, okay, it will be a little overkill for data warehouses. In case of data warehouses, your usual Hive or HDFS will suffice the need. Okay, although it's okay, completely okay to use a NoSQL in data warehouse too. All right. So Lakshman's question is: Are and SAP HANA and IBM Blue considered NoSQL DB? Yes. So SAP HANA, if I understand correctly, it is in-memory database which can be deployed on multiple machines. In that sense, SAP HANA is a good NoSQL. And IBM Blue, I have not. Do you mean IBM Blue Mix or something else? IBM Blue Mix, as I understand, is okay. So there is something called Blue. I don't know that. Okay, maybe I need to look it up. All right. So yeah. So these are the four kinds of databases, and this is a quick overview of comparison between SQL databases and NoSQL databases. All right, there is a question from Sanjay. Which of the NoSQL databases are the most popular in each of these four categories? All right. So in case of column oriented or wide column, HBase and Cassandra are quite popular. Okay. In case of document oriented, MongoDB is probably the most popular out of these. In case of key value, only Redis is being used. Rest are not too much in use right now, because key value, it makes sense as of today only in the case of in-memory databases. Okay. While in case of graph, it is Neo4j which is most popular. Rest are not. All right. And this is a classic comparison where SQL used to have only one type, which was based on CORD's, CORD's architecture. And the development of SQL databases started in 1970s, while NoSQL started in 2000. Examples of SQL databases is MySQL, Postgres, Oracle. While in case of NoSQL, there are around hundreds of databases, including MongoDB, Cassandra, HBase, and Neo4j. And data storage model in case of SQL database, everywhere it was relational, meaning there were tables and there were columns and there were rows and there were joins. In case of NoSQL databases, it all varies based on the data type. Schemas in case of SQL database, structure and data types are fixed in advance. Here it's dynamic. Most of the SQL databases had to be scaled up only vertically. There was no provision to divide a database table onto multiple machines automatically. Okay, even if we divided a table onto multiple machines, the relational properties and transactional properties were difficult to handle. And Therefore, almost every NoSQL was scaled vertically. Though we did sharding as in send all the users from India to one database, send all the users from US to another database, but still it was not really horizontally scalable. Now, development model in most of the SQL databases was proprietary, except for MySQL, rest of the databases were proprietary. Almost all NoSQLs are open source, and all the SQL databases support ACID transactions, and in case of NoSQL databases, it support document level version. And so, in case of NoSQL databases, also there is some support of transaction which is record wise or which is database table wise, but nothing like multiple database table or multiple transactions in a single shot. So the transaction support is very rudimentary in almost every NoSQL. Data manipulation and data storage, in every case, the data DDL and DML both were in the form of SQL in the SQL databases, while in NoSQL it all depends. There are different APIs, and some of them do provide SQL kind of interface. Consistency, SQL databases are configured for strong consistency, and you can also read the dirty writes, but they can be configured for strongly consistent. Okay. Now, in case of NoSQL databases, it all depends on the product. So Lakshman's question is, can you tell me the difference between HBase or Cassandra? Does Cassandra work on H? So we will take all of these details at a later point of time. You will have more clarity and more idea about on what basis are we comparing. Okay, let's take it at later point of time. All right. We will actually, in the last session, we will actually compare quickly all the databases available, or all the, I mean, the most prominent one, 4 or 5 databases are there, which are most prominent one. We'll just compare those and we'll understand in what circumstances do we use what. All right. Now we have been talking about something called consistency and acid properties. Some of the researchers realized that it is not really possible to provide the strong consistency in case of databases. So one of the researchers called some Brewster came up with the idea that out of consistency, availability, and partition tolerance, at a point of time, a system can only provide at most two, either C and A or A and P or C and P, not all the three. Okay, I will try to give you a couple of examples on explaining why is it not possible, and let's see if I'm able to explain that. Okay, so cap theorem says that out of C, A and P you can only at most get two. C for consistency, meaning all the nodes, all the clients, or okay, let me try to put it this way. When you are accessing a database, if all the nodes see the same data at the same point of time, that means the database is consistent. It should not be that I have read some data and then there has been no transaction, and then after a millisecond you are reading the data and we are getting two different information. That is inconsistency. Or I have just written something into database and I've tried to read it afterwards, I'm getting an older version of the data. So then the database is inconsistent. Second is availability. Okay, so your database should be available. Okay, a guarantee that every request receives a response about whether it was successful or failed. No request goes unanswered. That is called availability. Third is partition tolerance. Partition tolerance means if some of the machines or if some of the machines go down in our network, or network cable has broken somewhere, still the system should function correctly. It should not behave or misbehave in any way. Okay, so can our system can this database tolerate partitioning? Is it strongly or highly available? Is it consistent? These three questions are something which a database need to answer. But none of the databases have been able to answer yes to all the three. Okay, and that's what CAP theorem says. So this diagram vaguely displays who lies in what side. Okay, this diagram vaguely tries to display which database lies where. So you can see that in consistency and partition tolerance side, okay, you have big table, hyper HBase, and others. All right. So we'll go into the details again. Let's first understand why CAP theorem is valid. Why can't we get all the three of consistency, availability, and partition tolerance? All right. Let's try to understand what does it mean by CAP theorem here. Let's take an example. Okay. All right. How do you take it? All right. Oh wow. What happened to my data? All right. So let's have a look at these architectures. So let's say there is a database which has only one machine in which all the users are writing as well as reading. Let's take the case of the first one. So all the users are reading and writing to this single machine. Okay. So what happens is that this machine is since it is the one which is receiving all the requests from all the users, it is consistent, meaning whatever a user writes, if it tries to read the same data, it will get the most recent data. Okay, it would not receive stale data. Neither there is a difference between two users which are reading at the same time. So therefore the data is strongly consistent, but it is not highly available. It is not really too much available because all the users are talking to this machine, and every machine has got a limitation on number of requests that it can handle. Therefore, some of the requests will go unanswered. All right, let's have a look at the second diagram. So this is the model where RDBMS, this is the behavior which is shown by relational databases. Now, let's imagine there is another kind of databases you have built, or there is another kind of database that is available in market in which there are two machines. It runs on two machines, say A and B. all the users, all the writers are talking to A, meaning the data is being written to A, and then data is being replicated to B, and from B, all the readers are reading the data. Sounds great? And this is the model followed by MongoDB and others, where all the users will write to one system, and there will be multiple such systems like B from which machines can read. Okay, so readers, because readers are generally higher in number as compared to the writers, therefore, you generally have more machine from which the users can read the data. But there is a downside of this approach. It is, although it is heavily available, also we did not talk about partition tolerant earlier. So if this machine goes down in case of RDBMS, because it's a single machine, in case of RDBMS, the first diagram I'm talking about, I've gone back to the first diagram. So if this machine goes down, neither readers nor writers will be able to do anything. Okay, that means it is not partition tolerance. It cannot tolerate the partitioning in the network. All right. Now, in case of second scenario, it is if machine A goes down, B still contains data, but and also since the number of users are distributed, it is highly available as opposed to the one system machine. All right. It is not consistent. The only problem with the second diagram is it is not consistent. Why? Because all the users are writing to A, and if the same user who has written to A, after half a millisecond, if it goes to read, it will be redirected to B, and if it will get the older data, because data is still getting transmitted from A to B. It's on the way. So it takes time for data to get replicated on B, and therefore it is not consistent. Or you can say that user 1 has written data to A into some table somewhere. Same table is being read by another user after 1 millisecond. That user will get the older data, not the data which this user has recently written. Therefore, the second diagram is very clear that it's not consistent. Instead, it is eventually consistent. In a long run, in 5 minutes time or 10 minutes time, everything is going to be okay. It is going to be eventually consistent. Next is the HBase or HDFS kind of databases, where you have two machines, A and B, where all the users, all the read writes are happening on A, and A is replicating data to another machine called B. Okay, in case A goes down, there is a machine called B having exactly same data to which these users can talk to. So this kind of architecture is partition tolerant, as in if A goes down, there is B. If B goes down, A is anyway functioning fine, but it's not available in the sense that this A is a bottleneck. Okay, if you remember, it is name node and data node kind of model, where we are writing, whenever we are creating a file, we go to name node and create an entry, and that A makes a copy everywhere. Okay, so A is this name node is keeping a secondary name node for a copy of this. Okay, therefore there is a it's not name node is not highly available. Okay, so if you have anything else in mind, you can tell that now. Okay, if you have any other architectures in mind other than these three, I could not come up with any other architecture. Oh, is are these clear to all of you? these three structures. One is single node, other is two nodes in kind of a series where we are writing to A, reading from B, and the second one also in the series where we are reading, writing from A, and B just being kept as standby. So are these three structures clear to you? So while first one is consistent, rest two, second one is not, third one is consistent. So Sanjay is saying how is not available, the first one. It's not considered highly available. Okay, that's why I've marked it, crossed available. It's not considered highly available because there is a single machine which is being used by all the users. So in case this, there will be a queuing, and therefore it's difficult to handle the availability. Okay, some of the users will not be answered by this system. Neither the last one is also not available because the total number of requests are hitting only one machine. Okay, now there's a question from Lakshman, and right, so question is, Oracle kind of does third option through replicated database. That's correct. Anywhere there's a replication happening, whether in your normal RDBMS or any other way, the first one get converted into the last one. All right. All right. Before we move forward with HBase, we would like to understand what does it mean by column-oriented database. Okay. Are you with me? So you will hear this definition again and again. So let me make it very clear. What does it mean by column-oriented database? Okay, column-oriented database means that the data is getting stored in a column-wise fashion. In a row-wise fashion, we store things in the manner 10, Joe, 12, Mary, 11, Kathy. Right? 10, Joe, 12, Mary, 11, Kathy. This is how we store data in row-oriented databases. On the disk, on the disk, this is how we store first row, then second row, then third row, and so on. But in case of column oriented database, the way we store is very different. We store first column, then second column, then third column, then and so on. Okay, so you can see that 10, 12, 11, Joe, Mary, Kathy. That's how we have stored the data in case of column oriented. Although from the user perspective, from the usage perspective, a column oriented database and row oriented database would look exactly the same. For an end user, on both the tables, he'll see, okay, there are columns, there are rows, and there is a table name, and so on. Okay, but under the hood, there's a big difference. And the reason is that if you try to compress this data, there are two reasons why column oriented databases are better than row oriented database. Okay, first is the compression in case of column oriented databases is far better. Why? Because if you try to compress the column first, the output is better. Okay, why? Because generally in a column you try to store similar looking things. Okay, and therefore it's easy to compress them, easy to create a symbol for each of them and replace them with a symbol. Okay, so basically the way compression works is There is too much of duplication or too much of similar looking data is there in certain data set, it's easier to compress by eliminating the duplication and marking it by some other alias. Okay, so so that's the reason why column oriented databases are best suited for big database. Okay, whenever it's a big data and you want better compression, you go for column oriented. The other reason behind having the column oriented database is that the data in a column, if it if we are accessing the data in a column together very frequently, it makes sense to store it together. And that's what happens in most of these large systems, that when you are accessing the data, you access the data in a column together. Okay, so first is compression and second is access pattern. Those are the two reasons why column oriented databases are best suited for big data. Okay, so for that matter, Cassandra as well as HBase both are column oriented. Is column orientedness clear to everyone? Should I move? I'm not seeing any question from you. That's the reason I'm little too worried. Lakshman, Sanjay, Ravikant, Vidya, Anandita, Sarvana, Lloyd, Richard. Are you guys with me? I'm not getting questions from you. That's why I'm little too worried. All right. So keep asking question that keeps me in the context as well as that keeps the discussion going. And maybe others are also having the same question. It's just that they are not asking. All right. Now, HBase takes a clever approach. We will talk about this clever approach where they go with column family oriented. So they say that we are neither column oriented nor row oriented. We are column family oriented. Okay. So what does it mean by column family oriented? So what they do is what they have done is in case of column family oriented database, they group the columns into column family. For example, CF1 is the first column family to which employee ID and name belong to. Second column family is age. Okay. So in case of column family oriented databases, what happens is the way you store data is you store the column family together. Okay, meaning all the data of column family 1 gets stored first, then column family 2, which means these records will be stored first and then these records. Okay, so these records they are stored like in a row oriented fashion: 10 Joe, 12 Mary, 11 Kathy, and then 23, 33, 45. Okay, so you store a column family in a row oriented fashion. Okay, and then you store another column family, and that's how this column family oriented database works. So a quick question to all of you, if you are with me. Okay, a column family oriented database with one column family for all columns behaves like a column oriented database, B, row oriented database? C. None. A column family oriented A column family oriented database where there is only one column family, will it behave like a column family oriented database? Column oriented database or row oriented database or neither? Correct. It will behave like a row oriented database. Good. Very good. Brilliant. All right, we have two good questions. Let me ask two more questions and then I'll answer your question. All right. Now, same question in a different way. In a column, in a column family database, having one column family for each different column family for each column behaves like if we have one column family, I think, okay. Let me try to ask it in another way. Let's say there is this table in which we have created column family, one column family for employee ID, say CF1, CF2, and CF3. It will behave like row-oriented database or column-oriented database. Correct. Great. It will behave like column-oriented database. All right. Brilliant. Brilliant. So now you understand the reason that in case the column family oriented database is the most political approach or most correct approach a database could take, because you can convert a database into column oriented or row oriented by carefully selecting the column family. All right, or something in between. Now, there are two questions. Let me answer them. These are very good questions. So, first question from Sanjay is, can we redefine column family? In case of no, in case of HBase, answer is no. You have to create a new table with new column family and then push the data, transfer the data. Second question from Kanaga is, how does it affect compression? Okay, can anybody else answer it? Let's say there is a column called column called what do you call, okay, let's say there is a column called gender. Okay, and the gender is containing the values like mf mf ffffmm. Okay, now if you have to compress this data column wise, right? If you have to compress this data column wise, you could say things like mf, how many times? 1 2 3 4 5 6 7. Okay, mf7m, right? Do you see the difference? So it's easy to eliminate the common values and replace them with some symbol in case of a column oriented database. Reason being, when you have similar looking data, the chances of replication together is higher, and hence compression is better. Okay, and actually it did not strike to lots of people in the first shot. It came from statistically proving this point. On a billion records, somebody took the effort to actually putting across this point that, see, here I'm trying to compress columns first, and here I'm trying to compress the rows first. And the overall compression in case of column based was higher. So it was empirically proven. All right. So I'm trying to display. All right. So Lakshman's question is, when do you choose either? Okay. So in case of HBase, we will go into this discussion of how to carefully select the column family, and that would probably answer your question better. Okay. Okay. Thank you, Sanjay. He says that gives a hashed key to each duplicate data in the column. Yeah, that's another way to explaining why it would impact the compression. All right, that's pretty much for today. We will start our H-based discussion from next session. Okay. So far we have covered what is NoSQL, and we have completed our H-base, Pig, HDFS, Yarn, and MapReduce in detail. Okay, we will continue this discussion from next session, and we, till then, please finish your assignment, and as and when you are finishing assignment, let us know. Okay, because we are not generally sure whether you have finished or you are in midway. Okay. All right, thank you very much. Have a great day ahead. Thank you, Sanjay. I'm happy. Thank you, Joshi. Thank you, Sharuna. Thank you, Vidya. Thank you, Lakshman. I hope you're liking the session. Thank you, Lloyd. All right. Good night. Have a great day ahead. Bye bye.